Alright, this is question 7.37. It's I did it in class for some of the classes, but maybe not in others. There's a sports car. I'll just draw it as a circle. A, that collides or rear ends SUV, I'll call that B, and they stick together and then slide forward for a certain distance D before coming to rest. And what I'm going to do is I'm just going to solve for letters because you guys all have different numbers for this. So the mass of the sports car is MA, mass of the SUV is MB, speed of the sports car is VA, the SUV is stopped, so that would be 0. And I think what you're solving for is, well, you're looking for this, the speed of the sports car, and they tell you what mu is between the tires and the road. So when I see a question like this, whenever I see sliding to a stop, it makes me think of the work done by friction. And in this case, the two cars together have some combined velocity, which gives them some kinetic energy. And that work done by friction will decrease that kinetic energy. So if you subtract that, eventually, if it stops, it tells you that that subtraction will yield 0. Or in other words, the kinetic energy is equal to the work done by friction. So if you set it up, it's 1/2 M A plus MB times V combined after they've locked together. I'll put a prime there, I guess. Prime there. That squared equals, now the work done by friction, the way we calculate that, it's equal to mu Fn, that's the force of friction, times D. And it turns out that Fn for a flat surface is just equal to the weight. So this is mu Ma plus Mb times G times D. Sorry, I ran out of paper there. So doing that, you can solve for what V combined is. You're going to get radical 2 mu G D, whatever that ends up being for your numbers. Then what you can do with that is go back to this part of the problem, which is a sticky collision, right? And P before equals P after, that still holds. P before all comes from the sports car, so it's just MA VA, and again, this is what we're looking for. P after is, it's sticky, so you have MA plus MB times V combined, which is what you have right there. So you've plugged in all your givens over here. You can plug it in over here, V combined prime. You have that, divide your MA over, and you get V of the sports car. Whatever it ends up being. Okay? Hope that helps. Oh, side note here. Somebody in my second period class asked about water rockets, and there was an example, like one of the tutorials. There's one equation that I actually never remember it, but I looked it up today, and it tells you that the thrust of a rocket is equal to the rate of exhaust times the speed of the exhaust, or the velocity of the exhaust. So that's what it looks like in words, but in terms of an equation, this is going to be F. The rate of exhaust is your delta M over T, so it would generally be kilograms per second, times meters per second, or just V. I guess I'll leave it as V. Where's my eraser? Times V. And usually it's a gas, so we'll call it V of the gas. If you want to take it further and find what the acceleration is going to be ma. If you assume that you're far enough out where there's no gravity, so in deep space, g is 0. Obviously, this wouldn't hold on Earth. You can solve for what a is, and it's just going to equal delta m over t, times v the gas over the mass of the rocket. All right. So again, you don't have to use this for the test, but I just thought I'd show you where that sort of comes from. I'm still not exactly sure where this comes from. I'll have to do more research on that.